Hello and welcome to Learn ADS in 5 minutes. This is Tutorial 52 on automatic EM circuit co-simulation. Here is the agenda for this video. We will look at basics of setting up automatic EM circuit co-simulation, and then we will look at specific steps which you need to perform in order to set up this kind of analysis. And not only that, I will also touch upon how do you perform optimization while performing this kind of co-simulation. And the content presented here will make it very easy if you have to set up complex EM circuit co-simulation in a much easier manner. So stay tuned till the end of this video. And now before we start, subscribe to my channel. Once you subscribe, don't forget to click on the bell icon to enable all the notifications. And after you watch the video, give it a thumbs up and share it with your friends and colleagues who would be interested in watching similar tutorial. And like always, I always recommend you to put your valuable comments below this video to let me know whether this video was of your help or you want to get some further details into some of the topics which I am discussing on my channel. All right, so let's go ahead and start understanding each of these topics. Now, before we proceed with nitty-gritties of how to set up this kind of analysis, let me show you what you will be able to achieve at the end of around 10 to 12 minutes in this video. So here you can see I have a design which looks like a layout symbol, and basically it's a co-simulation design, and underneath we do have all the lumped components already integrated along with the layout. And in this analysis, I could simply, run the simulation as we am looking for, whether it's an S parameter simulation or harmonic balance, etc. In this case, it's a simple S parameter simulation, and you can see it works without any problem. Not only that, we also have a couple of optimization goals here. And underneath this schematic, we have lumped components which are defined as tunable or optimizable in a certain range. And while setting up this kind of analysis, I could also perform optimization with great ease. As you can see here, under optimization window, I do have these capacitors and inductors, values of which got optimized during this process because your layout is constant. But in case your layout was also parametric, that will also get optimized if you choose it to be. So hopefully this gives you interesting agenda for this session. So let's go ahead and learn how do we set up each of these steps in a sequential manner. So let me close all the designs which I have open currently, and let's look at the schematic first. So here is my schematic design, and it's a low pass filter just to keep things simple to explain the concept. And you can see I already have interconnecting microstrip lines, which I have used from the transmission line library. Along with that, I also have these LNC components in my design. And then you have a ground provided for the shunt components. So this looks like a pretty decent schematic design. Now also I already have layout created for that design. So here you can see you already have those transmission lines, and these are the inductors in series and capacitors in shunt. And if I double click on any of those components, you can see it has an inductance associated with it. All right. Now, if I have to set up an EM simulation or EM circuit co-simulation using the traditional techniques, I will have to delete all these discrete components from my design, and then we insert these pins at the connection points where later we would like to integrate these components in a schematic. Well, that's how the traditional things work. And those are easy things to do if you have very few components. But what if the design which you're simulating has 40 or 50 components? Inserting those many pins manually, assigning, each of those relationships can be really complex. So here, when we go to EM setup, and let's create a new setup, one thing which you need to choose here is the simulator. So let's say for this example, I'm going to use momentum microwave. Then you see two types of setups. So the first setup is what commonly we have used till now. And this is what, if you're doing an antenna design or a pure passive simulation, you will end up using the first mode. But in my case, where I have mix of the circuit elements and the transmission line elements, I could also use EM co-simulation view. So now once I use the co-simulation mode, notice what happens here at the bottom. So for EM simulation, it's actually in the simulate mode because it knows it's a self-containing layout and you can go ahead and directly perform simulation. But when I switch it to co-simulation mode, I'm telling ADS or simulator that I do have some things which may not be simulatable by the EM simulator. Hence, the option here changes to view. That means it will allow me to generate a EM co-simulation view containing all the definitions. All right, so hopefully that is clear. Now, once I change the mode here, I can go to partitioning option. And here I'm going to partition my design and decide which components are supposed to be EM simulated and which are supposed to be circuit simulated. So here you can see I have few components at the top and all of them are circuit elements. So instead of simulating it by EM, I can always change their mode to circuit. Now, if you have a lot of components, you only need to define it once or declare it once. Then you can right click and copy, select rest of the components where you want to assign circuit role, right click and paste. So with these two simple clicks, you have partitioned your design into the layout set of objects and the circuit set of objects. Now you will see this eye icon here. That means your partitioning requires a refresh. Simply click on this refresh icon and everything will be synchronized. And if there are no errors or warning, everything will be clean. This is how simple it is, no matter you had 50 components or 100 components. Now, once everything is done, obviously rest of the step remains the same. You select the substrate, set up your frequency. So let's say here, I'm going to simulate it from DC to 1 gigahertz. And rest of the stuff in terms of co-simulation, you can give your view any name you want. And this is the suffix, which will get attached in front of the design name you're using. So test LPF with LC underscore EM cosim is the new cell which we will create out of that, and that will contain the view as per the partitioning definition we have created. So let's see how this works. So let me click on go, and once it is completed, you see a successful message. Let's close that. Let's close it and let's go back to ADS main window. Now in ADS main window, see just below that cell, you have this underscore EM cosim. Now what's inside that cell is the layout. And what is this layout? If I double click, you can notice it has the pins automatically assigned for you at the component places. Now, how does ADS know where to assign pin, whether to keep it on this edge or at the center, whether it's a point pin, edge pin, or an area pin? All those definitions come from the definition of the component. So here I'm using ADS built-in component, which has this area pin defined. You can notice the blue rectangle. And this is representing the area pin. So this entire rectangle is supposed to be a pin. So accordingly, you can see, all the components have their pins automatically assigned. So this layout is the one which actually will get EM simulated. And once you have the data available for that layout, you can notice here the EM cosim view, which got generated, which has the information about your circuit components, which it will automatically integrate. So now the job we have is only one step remaining when we did this partitioning. Now I just need to create a symbol so that we can place that into another schematic. And again, the source view will be layout. And I would like to generate a layout lookalike component. And let's say I would like to keep sizing scale factor of 3. And once we do that, notice this symbol, which you only have 2 pins, which you want to connect in a schematic or test bench. Remaining inductor, capacitor, all those pins you don't need to worry about. ADS is automatically going to integrate all of that for you. So let's save this, and now we can go back to a test bench which I have created to test this filter. So here is my test bench which I can use to test my co-simulation. You can see it's a container with similar goals and the specification. And now let's drag and drop this symbol which we created. And now notice we only have 2 pins in that symbol as we expected. Now, if I try to simulate it, I need to first select the right view. So let me go ahead and first select the schematic view. So once I select the schematic view and I try to push into hierarchy, you will see the same schematic which we wanted, right? So let's go ahead and simulate that and now see the response of the filter, which is obviously as expected, right? So no great surprises here. Now I'm going to change this view to EM Cosim view, which we just created automatically, which has a layout plus all the components behind the scene. And once we do that, so let me close this job manager for more clarity. And once we go ahead and simulate, notice it is going to launch a EM job manager and it is running momentum simulator because that's what we selected behind the scene. It runs EM simulation, attaches the LNC components, and now you have this co-simulation response. So for comparison's sake, let's switch on the history, go back to our schematic, and let's switch the view quickly to schematic just to show whether these are two separate simulation or this is a marketing stunt. And here, as you can see, of course, there are two separate simulation. The solid trace or the thicker trace is your schematic results, and the red traces are your EM co-simulation results. And in both of these cases, you're passing the specification. Now, how do you do this kind of specification? How do you do these custom limits? There is a tutorial video coming for that, so stay tuned for that video. Now let's go ahead and switch off the history. One final thing before we end the video, so let's switch back the view to EM Cosim. Now while you are EM Co-simulation view, how can I perform optimization? Where are your components? Your component definition is already there in your schematic design. And notice here, your inductor, capacitor, all these components have been declared optimizable already, right? So you don't need to do anything extra because your base schematic already has all those definitions. So now here you could simply click on optimize, and now optimization will start running by taking your EM data from the EM results and the circuit models from your circuit design, and you would be able to do this kind of hybrid simulations very easily. So hopefully you like the content presented here and you would be able to utilize it for your applications to make your EM circuit co-simulation job very easy to perform. Thanks a lot for watching this tutorial and wish you all the best with your circuit designs.